Okay, we're going to review density. I have a few pieces of, they're all plastic, but they're different types of plastics. They're regular shaped, so they should be easy to find the volume. They're all a rectangular prism. So we are going to find their volume. Remember that density is equal to mass divided by volume, just like we've done before. Mass divided by volume. I wonder if this is backwards. I hope it's not. Anyway, so the first thing we're going to do, since we have to know the mass, we are going to take the mass of our shapes. So the first shape is number 1. And its mass, when I put it on the scale, is 107.5 grams. You'll want to record that on your paper. The next one is white, and this one actually feels lighter. It's not exactly styrofoam, but it's light. I'm going to put that on here. This happens to be number 16, and its mass is 44.5. You'll want to record that on your paper on canvas. So number 16 is 44.5 grams. This happens to be piece number 5. It's kind of a milky color. It is 61.7. 61.7. And piece number 11, which is clear, you can see through it. We'll put that on here. And it is 52.6. So to repeat those, the first one, number 1, is 107.5 grams. The second one, number 16, is 44.5 grams. The third one, number 5, is 61.7 grams. And the last one, number 11, is 52.6 grams. Okay, now we need to find their volume, because we have to take mass divided by volume. So I've got a handy dandy ruler. We have to stand up for this. And remember, you need all 3 dimensions of the block. I always pick a corner and measure the edges off of one corner. That way you don't accidentally measure 2 of the same dimension. And we always do metrics, so I'm going to measure in centimeters. This one looks like, make sure I got it exactly on the end. This one looks like 9.6 length. Okay, so I'm going to measure this edge. And 2.5. And then this length, I measured the 3 edges off of one corner. Make sure it's exactly on 0. 4.7. Okay, so piece number 1, length is 9.6 centimeters, width is 2.5 centimeters, and height is 4.7 centimeters. And if you missed it, the mass was 107.5 grams. So now that you got all that recorded on your lab paper, we'll go to piece number 16. Again, I'm going to pick a corner and I'm going to measure the 3 edges so I can get all 3 dimensions and not accidentally measure one dimension twice. The ruler I'm using is an I-step ruler, and if you recall, it starts on 0, so I put the very end of the ruler down, and I get 11.3. So piece number 16, the length is 11.3 centimeters. You may remember that it doesn't matter which dimension you call length, which you call width, and which you call height. The reason is, I would probably call this length here, but not if I was looking at it this way. So it doesn't matter which you call which as long as you have all 3 dimensions. Okay, and I'm going to do 1.9 for width. And then the other dimension is height. I'm being very careful to get the end of the ruler on here, and it looks exactly 3.5. So Piece number 16 is 11.3 centimeters by 1.9 centimeters by 3.5 centimeters, and if you recall, has a mass of 44.5 grams. All right, now we're moving to piece number 5. Again, pick a corner and get the measurements off that corner. I'm going to do the length first. Whoops, wait a minute, I need centimeters. 8.5, and then the width, 2.3 centimeters. Kind of switched it around here. And this dimension is 2.4. Hang on, let me make sure I got this right. Nope, wait a minute. I had to measure 2 dimensions twice. Oops. 3.3 is the height. 3.3. Okay. On piece number 5, the length is 8.5 centimeters. The width is 2.3 centimeters. The height is 3.3 centimeters, and the mass was 61.7 centimeters. The last piece, the clear one, measure the 3 dimensions, 4.5 centimeters by 2.3 centimeters. And the height is 4.2 centimeters. All right, and again, piece number 11, the clear one, length of 4.5 centimeters, width of 2.3 centimeters, height of 4.2 centimeters, and a mass of 52.6 grams. So what you're going to do is you're going to complete this by calculating the density of all 4 pieces.